will never remove the last F application. You see? You have to get rid of two F applications, but, well, this equates an expression with two F applications to an expression with one F application, so you can get rid of one. However, F occurs at both sides of the equality, and therefore you can never get rid of the last one by a rewrite rule. So, just counting the number of symbols, the changes that have to be made, will lead you to the proof. I used that to prove two theorems from a book by Alfred Tarski on logic, two theorems from group theory, which he included in his book as more complicated examples. Just by using this counting technique, I proved his simpler example, and his more complicated example, I even came up with a simpler proof than Tarski's. No. Perhaps you don't think this important. If Tarski has already proved it, why come up with a shorter proof? Well, to say the honest truth, in the combination of theorem and proof, I usually think the proof of greater cultural significance than the theorem. Yeah? It's totally fantastic if you realize that several centuries before Christ, Euclid and his friends took the trouble of proving that the number of primes was unlimited before they knew that, there were enough primes for their needs. Yeah? But they took the problem, they took the trouble to show with a beautiful argument, a shining gem from antiquity, that the number of primes is unbounded. Yeah? And it's my private definition of a reusable theorem. It's a theorem that can be proved over and over again. Yes, sir.
Your examples seem to all have symmetry, and when you found the symmetry, you were able to reduce the count of the argument. Is that mathematically rigorous, and if you can find the order of the symmetry, you can reduce the number of arguments by the order of the symmetry?
No, it is a time-honored rule of thumb. Never destroy symmetry lightly. Sometimes you have to. Yeah? But never destroy symmetry lightly. And there is that terrible thing. If all traffic keeps one side of the road, if everybody keeps the right side of the road, then oncoming traffic doesn't clash. Yeah? If everybody takes the left-hand side of the road, it's okay as well. So we end up with a world in which half of the traffic has made the one choice and part of it has, yeah? The fact that we do not have a good notation for the unordered pair may force us to quite arbitrarily introduce the one versus the other. It's a tremendous nuisance that we do not have them. Shall we call it a long Tuesday? Yeah? Okay. Thank you for your attention.